Imagine standing at a crosswalk. The light turns green. Before you step off the curb, you look left, you look right, and you check for cars. You actively collect information from your environment, process it in your mind, and decide it is safe to walk. Because humans make decisions using life experience, common sense, and sometimes even emotion, it is easy to assume artificial intelligence does the same. But an AI possesses none of those traits. It operates entirely without feelings, imagination, or instinct. Instead, it relies exclusively on raw data and mathematical patterns to choose its next action. What we often call artificial intelligence is a highly mechanical process. It takes raw, measurable information and translates it into a calculated statistical output. Every decision an AI makes follows a strict three-step architecture. Step 1 is collecting information, or input. This might be a photograph, a voice recording, a GPS location, or a block of text. Without this initial raw data, the system is completely blind and cannot function. Step 2 is analysis. In this animation, you can see the system actively scanning a chaotic stream of raw data. It compares the new input against everything it learned during its initial training, searching for recognizable patterns, similarities, and relationships to group the information together. Step 3 is the prediction. After analyzing the clusters, the AI selects the single answer that aligns most closely with the mathematical patterns it discovered. This output is an educated guess based on historical data. The AI does not actually know the future, nor does it truly understand what it is looking at. It executes a sequential pipeline: collect data, analyze patterns, and project the most probable mathematical outcome. To understand how that analysis actually works, we have to look at how AI identifies objects using specific, measurable clues called features. If an AI is trying to identify an animal, it extracts specific features from the image, like the presence of 4 legs, pointed ears, fur, and a long tail. It takes those extracted features and compares them against millions of known examples stored in its training data, looking for the closest match. As you can see in this interface, the AI calculates a mathematical percentage for every possible answer. This is called probability. Based on the features it detected, the system determines there is a 4% probability the silhouette is a wolf, a 1% probability it's a fox, and 95% probability it's a dog. That 95% represents the system's confidence. Confidence is the internal metric indicating how strongly the AI believes its highest probability score is the correct answer. Software engineers program these systems with specific confidence thresholds. A smartphone facial recognition system, for example, will only trigger the decision to unlock the device if the confidence metric is exceptionally high. Ultimately, an AI's decision is never an absolute certainty. It is the statistical winner of a rapid, complex mathematical contest. Because AI relies on probability rather than perfect knowledge, it makes mistakes. When it encounters poor quality data, blurry images, or objects it has never seen before, its predictions can be incorrect. A subset of AI, known as machine learning, addresses this limitation. Machine learning allows the system to use its errors as stepping stones for growth, improving its accuracy with experience. The engine of this growth is feedback. Feedback is the critical external signal, often provided by human users or trainers, that informs the system its recent prediction was wrong. Here is how that looks internally. When the network registers a mistake, the pathway flashes red. The system immediately adjusts its analytical logic, rerouting and strengthening a new green pathway to represent the corrected connection. By repeating this loop of prediction, mistake, and correction millions of times, the system drastically increases its overall accuracy. The true power of machine learning lies in its relentless mechanical ability to refine its own logic through continuous feedback. That localized 3-step process is happening billions of times a second across the globe. Rapid probability calculations drive the consumer tools we use every day. They allow streaming platforms to recommend a movie based on your viewing history, and navigation apps to instantly reroute your commute based on live traffic data. In healthcare, the same pattern recognition process scales up to handle massive datasets. AI assists medical professionals by scanning thousands of MRI and X-ray records to detect the early features of disease. Global banks apply this exact framework to process millions of daily transactions, instantly identifying anomalous spending patterns to halt financial fraud before it clears. The core logic never changes: input, analysis, prediction. But the sheer speed and scale of that processing transforms a basic statistical tool into an invisible global utility. While computers excel at analyzing billions of data points in seconds, they lack ethics, empathy, and contextual common sense. They only know the data they process. This is why humans must remain the ultimate authority. In high-stakes environments like hospitals, courts, and commercial aviation, AI can suggest a highly probable outcome, but a human expert makes the final decision. Let's test what we've covered. True or false? AI uses emotions when making decisions. That is false. True or false? AI always makes perfect decisions. Also false. It relies on probabilities and can make mistakes. Think about an AI system you use every day, like a search engine or voice assistant. Try to mentally deconstruct it. What raw data is it collecting? What patterns is it recognizing? And what prediction is it making? These systems are meticulously designed to act as incredibly fast assistants, elevating human potential rather than replacing human judgment. Every artificial intelligence decision relies on the same life cycle. The system collects data, analyzes that data for recognizable patterns, and outputs the prediction with the highest statistical confidence. When we combine human creativity and responsibility with the raw analytical power of artificial intelligence, we create a highly effective tool for solving complex problems. But there is a vulnerability built into this system. If an AI strictly relies on the historical data it is fed, what happens when that foundational data is flawed? In our next episode, we will explore the concept of AI bias and why a purely mathematical system can still make unfair decisions.